Agent-substrate is a high-performance runtime for scaling agent applications. It provides a control plane that can create, suspend, resume and destroy agents in a matter of subseconds. It lets many agents share a small pool of physical workers by running them in lightweight sandboxes such as micro-VMs or gvisor. This sharing is possible because most agent workloads stay idle most of the time. The system is intentional in my opinion. It doesn't force a particular programming style or SDK, but instead manages the life cycle of actors, which are just applications running in containers. It is built to run on Kubernetes, using pods and auto-scaling for infrastructure management, and adds its own scheduling logic so that agent operations are low latency. Demo. A quick demo shows one cluster running roughly 250 stateful agents on just 8 Kubernetes pods. These agents can be instantly teleported between workers in less than a second. Their working memory and file systems are preserved across suspend and resume operations thanks to full-state snapshots. While the system is running, it can oversubscribe the workers by up to 30-fold, juggling many actors back and forth. The demo is available on YouTube, and you can follow the step-by-step walkthrough in the counter demo guide. Compatibility. Agent-substrate is agnostic to the framework in which an agent is built. Because it manages standard OC containers, it can host agents written in any language or framework. It has specific support for the Agent Development Kit, which provides a consistent identity and memory model. It also works well for LangChain agents, for Cloud-style coding agents that need to preserve terminal state, and for any sandboxed server that follows the Model Context Protocol. Ecosystem. A notable example of a production Railway runtime on Agent-substrate is the Agent Executor project, which demonstrates how to build a secure, hyper-scalable harness on top of the substrate. Status. Agent-substrate is in early development. The APIs are subject to change, and the system is not yet ready for production use. It currently targets the latest stable release of Kubernetes and the previous minor release. Community. Announcements and discussions happen on a Google group. The community hosts a weekly meeting on Thursdays from 10 a.m. to 11 a.m. Pacific Time. There are also dedicated Slack channels for users and developers. Getting started. To try the substrate on your machine, you need Go, kubectl, and Docker. The repository ships with scripts that automatically install a local Kubernetes cluster using kind. Set up a local container registry, deploy the substrate system and install a sample counter application. After that, you can create a namespace, launch an actor, and hot its HTTP endpoint to see state persisted across suspends. On Google Cloud Platform, the setup is similar. You create a GCP project, enable the necessary APIs, bootstrap the infrastructure with a helper tool, install the substrate, and then deploy sample demos. If you want to tear down resources, there are cleanup scripts for both kind and GCP. Demos. The repository contains several demos. The counter demo shows a stateful HTTP server that keeps counters across suspensions. The sandbox demo runs Alpine Linux inside a sandboxed environment while preserving the file system. The Cloud Code Multiplex demo posts multiple coding agents onto a small pool to show oversubscription. The multi-template demo runs two distinct binaries sharing one worker pool. The request parking demo shows how the router can hold requests until a worker becomes free, rather than returning a 503 error. The auto-scaled worker pool demo scales the pod count based on worker utilization. Documentation. The documentation covers many aspects of the system: architecture diagrams, API configuration, command line tools, glossaries of core terms, integration repositories, observability, authentication, threat modeling, and a roadmap. There are also guides on benchmarking with synthetic workloads. Tour of the code base. The repository contains several key directories. The CMD directory houses the executables for the control plane API server, the NAD-level supervisor, the controller that reconciles Kubernetes custom resources, the networking controller, the in-pod helpers for running sandboxed actors, and the command line tool kubectl. The tools directory contains a GCP provision and utility. Finally, there is a demos directory that hosts the sample applications used in the demos.